Just a little update. So first of all, I moved to this kind of double-decker design, where basically this is like the mounting plate on a regular keyboard that goes on top of the main PCB. Except this is actually going to be flush with the main PCB, and that's to better match the shape of the original keyboard. So basically, how it's going to work is you just take this and you stick it on top like that, and then you make the connection with castellated vias. So these are the little, it's going to be these little holes like that. And then the top plate is going to have pads where you connect solder. So when you flip this around, you can see like there's the pad, and when you put the pieces together, then it'll match up with the holes on the other side. Now this raises a problem, which is so you have the little components on the side of each switch. This is the diode, which prevents ghosting on the key switches, and then the capacitor for the LEDs. And the capacitor is not, they say it's not strictly necessary, but it helps protect your LEDs from damage from voltage fluctuations or whatever. Now the problem is, so these are going to stick up off of the main PCB, and the mounting plate is flush with no space. So that means there has to be a cutout for the SMD components on the side. Now the problem here is this, well, first of all, it's not going to look super nice even if I make like 3D printed covers for the holes, which is a possibility. But the other problem is this, it's, or at least my fear is it's going to weaken the mounting plate because this is not a very big space. So this leads to me, so now I'm leaning towards just getting rid of the RGB LEDs. Well, actually, I'll back up a second and say these are the addressable RGB LEDs. And so basically, well, okay, if I don't have if I use like non-addressable, and when I say addressable, it's like basically the addressable ones are they have a microcontroller on board, so you don't need an external one. And what you do with these is you just take one pin on the microcontroller and you stick it into the input on the addressable LED, and then you just daisy chain every other LED off of that. So they have an input, and then they also have an output where you pass the signal along to the next one, and so on and so on. This is what the corn uses. The problem is, first of all, you end up needing the capacitor, or well, needing, I don't know. But the other thing is these consume more power than regular like dumb LEDs where you'd use a separate controller to control them. And that's kind of an issue on if you're using a lot of them. Anyway, but the bigger issue is so back to the whole thing with the cutout holes. These, if I just get rid of them, then what I can do is take the diode and stick it under where the cutout is, because this is like normally under the switch there's a little place where you can put LEDs, but if I don't have an LED there, then I can put the diode there, and that solves the problem of the extra cutout, and it'll look better and be more stable. Also, if I make too many cutouts on the PCB, then they're probably going to charge me extra. So let me know if you actually care about the LEDs, because, well, actually I feel like I was the only one who even wanted them to begin with. Now I will say I don't have to make an entire plate in the first place. I could just have like a smaller like board that doesn't take up the entire footprint. It just like screws in on the very top. But I want to try the plate because I feel like it'll look nicer and it'll make things more stable. Oh, and I know I said I think before I was like, oh, I need calipers to do anything because I need precise measurements on the footprint. But reality is I think like I took ruler measurements and they're gonna be basically accurate enough to do most of the stuff I need to do, and then maybe at most I'll make small micro adjustments after the calipers arrive, which they still haven't because they're stuck in the mail. So yeah, that's that. Another thing, so when I send my design to the PCB supplier, they're gonna charge me for the rectangular area. So that means I'm gonna have all this empty space in these areas that's gonna be wasted. So what I'm planning to do is there's this thing called the Goldfish, which is an open source Elite C compatible controller. So I'm gonna take some of these. I'm probably gonna use the Olvaro because it has bigger components so you can hand assemble it. So take some of those and add them on to the edges so I can get more bang for the buck. I also got some of the hardware that I needed. First of all, to mount the top plate to the bottom plate, and also for the screw holes to connect or to mount the keyboard onto the laptop. And you're gonna need aftermarket screws because the specifications are different. So I made a list of all the screw lengths for all the different models that are being supported, and I ordered samples of all of that stuff. Here's the TrackPoint. So basically, there's going to be a hole here where the little stem sticks out, and then on the side, there's going to be screw holes where you attach the thing. Well, you attach it mechanically with the screws, and then electrically, there's going to be some more castellated vias on the bottom. So you just solder the pads here, and then it'll be connected up to the microcontroller. So this little, whatchamacallit, this is a solder jumper for the TrackPoint connection. So basically, if you connect this to pin D5 on the Elite C, then you can use the USART protocol for the connection, which is the best. But if you don't have an Elite C, then you're not going to have this pin available on the Pro Micro. So you're going to connect it to D3 instead for interrupt-based connectivity, which is still good. So so you would either solder onto this side for D5 or other side for D3. I haven't actually tried this, so when I get the prototype board, I'm gonna see if it even makes a difference really. Now let's talk about spacing. So I went with the USB-C connector for the split half connection instead of TRRS because TRRS is way too tall to actually fit in here. And the USB-C is gonna fit decently well. Now the other thing is the microcontroller. So I heard some concern about this actually scratching the screen. So what I'm gonna try is have the thing actually mounted upside down with a hole in the PCB. So basically, all of the top of the microcontroller is gonna stick through here on the bottom to try and minimize the footprint. So basically this cardboard is the PCB and then the Pro Micro is sticking through. And I've also ordered some low profile stuff for the hot swapping capability. A couple other things. And then I sort of threw in OLED header just because I had space, so I figured why not. And then over here is going to be the switch for reset. On the other side, there's going to be reset and power, and the power is going to be connected over here with the jumper. This is the reset switch from cAl. I don't know if I'm actually going to use this model. It will fit within like the original space, but I might go with a lower profile surface mount switch to play it safe. So let's talk about the next steps. Once I decide whether or not to do the backlight or not, then I can finish the first prototype. And then sometime around then, I'm probably going to do the interest check. And then I still need to wait for Mr. ThinkMods guy to actually release his USB adapters because my product kind of depends on his. I'll probably send him a message after the interest check being like, hey, I'm gonna order 69,420 of these products. Are you gonna produce them yet? So then after those are available, then I can do the group by. So I'm gonna post a poll in the chat room, I think, to say to ask whether or not we should have RGB LEDs. Let me know if you have any other feedback, and I'll see you next time.